Okay, today I will talk about the prisoner's dilemma, which is the one of the most famous example of the game theory. So last time we talked about what is the game theory. Game theory is the decision science when there is a multiple player, or each of players the payoff or the gain is affected by another player's decision. So their decision is interrelated. So how much I'm gonna get is depends on my opponent's decision. Also, my opponent's payoff is also affected by my decision. In that case, how they end up with their choice. That's the game theory. So as I told you, we assume the two players are rational decision maker, which means they trying to maximize their own profit or minimize their loss. Okay, so the prisoner's dilemma is about the why we call this a dilemma, because it doesn't come up with the intuitive result. So suppose there's two criminals, Tom and Jerry, and then they were caught by the police. The police doesn't have a strong evidence, so they can charge them with a minor crimes, but they suspect that there is the bigger crime. So they set these two criminals into the separate room, and then they try to integrate. And then they suggest, if you help us, I mean the police, if the criminal helps police, they can set the criminal free, but the criminal will stay a longer time. So these numbers, so like left lower corner is Jerry's number of years in the case, and the right upper corner is Tom's years of in jail. So they have two choices: it's a silent or confess. Silent means don't say anything, and confess means tell the police what happened. So if both of them keep silent because the police doesn't have a strong evidence about the big crime, so they will spend 1 year each in the jail. But if one of them confess, then the confessed criminal will be set free, and the other one will stay in jail 3 years. And if both of them confess, then they will stay in the jail in 2 years each. So obviously together, what is the best outcome overall? So Tom and Jerry are actually the silent 1 year each in jail is the best outcome, right? So, but remember, as I told you, we think our players are rational player, and then they trying to minimize the year of jail. Okay, so the result will be a little intuitive. Okay, think about the Jerry's point of view. So this lower right corner is the Jerry's year. So Jerry has two choices: silent or confess. So the number of year in jail depends on the Tom's choice also. So that's why this is the game theory problem. So Jerry's, if Tom, so let's suppose we are Jerry. So Jerry, if Tom stays silent, what should I do? So if Tom stays silent, and if we keep silent too, then we have to stay 1 year in jail. And if I confess, I can walk away. So 0 year. So if Tom chooses silent, we have to choose a confess, right? So confess is the best option if Tom chooses silent. So now the different cases, if Tom choose confess, so we are Jerry. So if you look at the number of years, 3 years versus 2 years, 2 years is a smaller year, so this is a better choice. So we have to confess. So either way, if either Tom choose silent, so 0 is better than 1 year, 0 is better than 1 year. If Tom confess, 2 is smaller than 3 years. So whatever happen, Jerry will choose confess. Okay. And also Tom's side, now if we look at the Tom's position, if we are the Tom, we can choose silent or confess. So if Jerry stays silent, which one should I choose? You can compare this 1 year in jail or 0 year in jail. So 0 year in jail is better, so Tom should confess if Jerry keep silent. So if Jerry confess, we have to compare these two numbers, 3 versus 2. So Tom would be better off to confess. So same thing happened. Either Jerry choose silent or confess, Tom will choose confess. So as a result, this will be the what we call the Nash equilibrium. Both of them will choose confess because we analyze the payoff. Whatever the opponent will choose, confess is always the better choice. So both of them will choose confess. Actually, they will stay the 2 years each in the jail. So in overall, this is the worst outcome because it's a 2 year, 2 year, 4 year. It's a 0, 3, and 0, 3, and 1, and 1. So obviously, as a society, I mean, as a group, silent is the best outcome. But because whatever the other member choose, confess is the better off. So actually, it will happen to the confess. Yeah, this is a theory, but is there the real example of the prisoner's dilemma? Yes. 1971. Actually, the advertisement of the cigarette was banned because the people think the cigarettes, the smoking is pretty bad for the health. So trying to reduce the usage of the cigarette, the government banned the advertisement of cigarette. So after that restriction of the advertisement, so you cannot see any advertisement of the cigarette in the TV. After that, they expect the cigarette demand goes down. But actually what happened is the cigarette companies makes way more money than the advertisement ban. This is the one example of the prisoner's dilemma question. So if we have two different cigarette company, you can do the advertisement or don't advertisement. So actually the cigarette demand is not that elastic to the advertisement because if you smoke, doesn't matter you watch the advertisement or not, you will keep smoke, right? So demand doesn't go down that much, but company doesn't spend the money, a lot of money on the advertisement. But when the advertisement was allowed, why they have to do the advertisement? Because if one company advertise on the TV commercial and the other one doesn't, actually the advertising company will have a lot of demand, so they make a lot of money, and then the company who don't advertising the commercial will lose a lot of money. So even though they know both of them will be better off without doing the advertisement, because one of them will do the advertisement, so they end up with the same result. So both of them will do the TV commercial advertisement. They spend a lot of money. So actually, in terms of profit, if both of them don't do the advertisement, they can make a way more profit. So that's why it happened. That's the one example of the prisoner's dilemma in real world. So that's what happened. So this is just one of the prisoner's dilemma problem, but we will go over a lot of different examples, the problems of the game theory next time.